Okay, let's look at the next example in the Boost multi-index documentation. In this one, they're motivating the interface index. I keep calling it an interface because that's kind of how I view it, as like a different view of the data. Essentially, it's the same data, but you're getting a different look at it, I guess. In this case, they're motivating the list, or what they call the sequence index, which allows you to view the data as a list rather than a set. So what they've done here is they've created this list of strings. They've split up this string that's from Alice in Wonderland based on various parameters, right? Tab, white space, new line, all that stuff. And then they insert it into the list. From there, they want to count the words and then remove words from the string, right? The problem with this is, in both cases, you have to iterate the entire list in order to support these operations, which is linear time, which is obviously bad. So what we want to do is we want to bring that into logarithmic complexity. The reason this is different than the employee example, right, is we still want to be able to print the string out as if it was the English sentence that we actually read in. If you tried to use the previous multi-index definition, right, you would get the strings in alphabetical order, or let's say we wanted to store the counts as the secondary index, right? You would get those in numeric order, right? Those are both bad things when you're dealing with sentences. You want to actually print those out in the order that they're logically make sense, essentially. So here they've done, similar to the employees one. They're storing strings in the multi-index, and then this is the new bit of syntax that they're showing in this example, is this sequenced index. And then we have the ordered non-unique one as well, which treats the things similar to the set before, but we can also treat them like a list, essentially. And what this allows for is you can get this sorted index in order to view it as a set, but you can still print out the words, again, logically as an English sentence. So you can do delete and count both in logarithmic time, which is supported by the sets. So what I did here is I just took, the same example, I coded it up. We probably don't even need to look at this, really. I mean, it's such a basic example, and we've already kind of gone over the multi-index, but, I'll just show, I guess, prove that, it does in fact work as I just said. So if we compile this, we don't want the multi-index one. Let's compile the list one first. And then print that out. Okay, so what I've done here is I've counted the word to, right, in linear time. And you can see there's 2 occurrences of the word to in this, so it looks like that one and that one, right? And then I delete it, again in linear time, do another count in linear time, you see 0. And then if we look for the 2 again, you can see it's gone from the sentence, right? But the problem is these are both linear time. This is not good. So if we look at the multi-index example, you can see that I'm using the same index here. I'm doing the same count, the same erase. We should get exactly the same output. Well, this is taking a long time. Okay, and as you can see, we counted the word to again, see, and we got 2 for the answer of that, and then we erased it, and you can see it's gone from the string. We did another count, and it's 0. Again, the thing to keep in mind here is that we can still treat this as a list, which is very, very important. Okay, we'll move on to the next section of the documentation in the next one. Again, if you get bored of these multi-index or you're not getting anything useful out of them, feel free to move on to the next section, but again, I'm keeping these as for my own reference as well, right? I'm going to go back and watch these videos later, probably anytime I get stuck or hung up on something while I'm writing blockchain. So see you in the next video.